Antarctica is a continent that is unique from every other continent in the world. It's a land covered entirely of snow and does not ever see warmer temperatures. Wildlife here is sparse, as the few animals that live here consist of different types of penguins, albatross, seals, and whales such as the killer whale. The Antarctic continent is the highest, driest, and coldest of the continents on Earth. Yet this continent is mostly populated by scientists from around the world conducting experiments and furthering research in their respective fields. Today we will discuss one field in particular, astronomy. As unlikely as it seems, astronomers do have a reason for studying on this continent that is far away from human settlement. The answer doesn't lie within the area itself, but the sky beyond. Captain Cook and the crew of the ship's Resolution and Adventure were the first people to cross the Antarctic Circle in 1772, carrying with them a collection of telescopes, quadrants, and chronometers, together with two astronomers, William Wales and William Bailey. However, the prime purpose of these instruments was for navigation rather than astronomy. Douglas Mawson's Australasian Antarctic expedition of 1911 through 1914 can be credited with first advancing the science of astronomy in Antarctica through the discovery of the Adelaide land meteorite. This was found on December 5, 1912, during one of the many sledging expeditions undertaken to chart the coastal fringes around Commonwealth Bay and Adelaide Land. It was not until 1969, however, before Japanese scientists found a number of meteorites of different types in close proximity and realized favorable conditions that Antarctica provides for their collection. The meteorites are transported from where they fall to ablation zones and blue ice fields, where they can simply be picked up off the snow. Antarctic astronomy began to flourish in earnest from 1991, following the formation in the USA of CARA, the Center for Astrophysical Research in Antarctica, the South Pole, with Doyle Harper, director of Yerkes Observation, a part of the University of Chicago. As its first director, CARA instigated research programs into CMBR and anisotropy, submillimeter and infrared astronomy, as well as initiating a site testing program. Australia, through the University of New South Wales, joined this last program in 1994 and began designing experiments to allow uninhabited high plateau sites to be evaluated. South Pole, at 2,835 meters elevation, lies on the flank of the Antarctic Plateau. While there are better places in Antarctica for many kinds of observation, the logistics of ready access have made the pole the place where most of the astronomy has so far been conducted in Antarctica. At the United States Amundsen Scott South Pole Station, named after the pioneers who first reached the pole in 1911 through 1912, the station was established in 1957 during the International Geophysical Year, also known as IGY. It recently completed a major refurbishment and supports around 60 personnel overwintering and about 250 in the summer months, if you want to call it that. Concordia Station at Dome C, built by France and Italy, was opened for winter operation in 2005, following a decade-long construction phase. At 3,268 meters, Dome C is one of the high points of the plateau, where the conditions are at their most stable. The highest location on the plateau is at 4,083 meters in Dome A, first visited by humans in just 2005 by a Chinese team on a tractor traverse from Zhongshan Station. In 2009, China began the construction of Kunlun Station at the site. Already several astronomical experiments have been conducted here, making use of an Australian robotics observatory. There are plans that are being formulated for IR and T-Hertz telescopes within the next decade. Two primary factors have driven much of the current interest in Antarctic astronomy: the coldest and driest places on Earth that are found in the air above the Antarctic Plateau. The cold reduces background fluxes in the infrared. See, infrared is electromagnetic radiation with wavelengths longer than visible light. meaning it would be invisible to us. By using infrared, we can detect distant objects through the use of heat energy. These instruments detect thermal energy and display the different temperatures in different colors depending on how hot or cold something is. That being said, with the cold air all around Antarctica, that makes using infrared instruments a lot easier to use in order to detect distant celestial objects with little to no interference from other sources. What makes Antarctica so great for astronomers is the thin atmospheric layer. The main advantage of Antarctica's thin atmosphere, apart from the hole in the ozone layer, well, at least it's been improving over the years, is the imaging quality for the instruments these scientists use. This means that the atmosphere above Antarctica does not yield the same amount of particles and gases that would normally be used to protect the Earth from cosmic rays. This helps observation by being like a direct window into the cosmos. This is not life-threatening, but it is noticeable enough on scientists' instruments. There are, of course, some disadvantages relating to the site conditions on the Antarctica plateau. The cold and high altitudes pose difficulties for humans, but are relatively simple engineering solutions for the operation of facilities. The sun also spends long periods of time just below the horizon at high latitude sites, meaning that the fraction of time is astronomically dark. Or, in other words, when the sun is more than 18 degrees below the horizon, is smaller than at temperate latitudes. Auroral activity in Antarctica is frequent, but its intensity varies over the continent depending on whether the auroral circle is visible. The South Pole and Dome F lie nearly just under the auroral circle, so suffer frequently, whereas domes A, B, and C lie just 6 degrees from the geomagnetic South Pole, so that the aurorae there generally lie below the horizon. In conclusion, the world is ours to explore, but just because a location proves difficult and more harsh than what we are used to, we can still take it as an opportunity to explore and further our understanding of our world and the world beyond.